Alright, silly people, here's the situation. We're going to be making a Python program that is going to calculate each of the prime numbers from 3 to 10,000 and print them out, pretty much, using a highly efficient method, more efficient than what Mark Newman came up with, and that's kind of the point. Because what it's going to do is we're going to start with a list that only has the number 2 in it, and then we're going to check every number from 3 to 10,000 if it's divisible by any of the primes in a prime list that we're going to update as we go, up to and including the square root of n. And the reason why we only check up to that value is the reasoning is explained in here, just some number theory stuff. And so just getting into the program, so like I said, we're going to start with a list that's going to only have the number 2 in it. So that's going to be the list of prime numbers, right? So that's that guy. We want to run over a bunch of different n's from 3 to 10,000. So let's make a for loop for n in range 3 to 10,000. Yeah. And we want to check if whatever n is actually divisible by stuff that is in the prime list. So let's also make another for loop inside here that is k, or k in the list of prime numbers. Then we check if the n is divisible by the k, right? But we only need to check the ones up to and including the square root of n. So we want to make sure that this is like if k is less than or equal to the square root of n. And I'm actually going to import numpy as np to try and get the square root function from that, so we don't have to do that manually. So if k is less than or equal to the square root of n, then we have another if statement that checks if the n is divisible by the k. So if n mod k is equal to 0, if that's the case, then the number is not prime. So we should create a boolean at some point, probably here, that says is prime. And we can assume that it's prime as we start the n loop, but then once it gets to the point where it figures out that it's not prime, then we make it false, right? False. Okay. After all of that, if it goes through the entire k loop and finds that none of the numbers in the prime list divides the n, then it ends up being a prime. So now we can check if is prime. We'll add it to the prime list first of all. So prime is dot append n, and we can also just print it out as we go, just for fun. And then at the end we can print out the whole list. So print prime ls. And I think that should be it. I mean, this code is pretty simple, all told. It's only more efficient than what Mark Newman came up with because he was checking pretty much every prime number and seeing if our n was divisible by all of those, but we're only checking up to root n, so it takes a little bit less time. And there are the prime numbers there. Yeah, those look right. Okay, and also it's all printed out here all the way up to 10,000, so pretty simple code there. All right.